Okay, this video is to help give examples on how to write verbal expressions as algebraic expressions. So in other words, if you're given like a word problem, how do you transfer it into a mathematical expression if that's what it's asking you to do? So in this case, we've got a ton of examples. Let's go ahead and get started. So on number one, all right, so number one says the quotient of 32 and x. So quotient is the key word here. Quotient means the answer to a division problem. So in other words, quotient, just think division, okay? So the result of a division problem is called the quotient. So if we're looking for the quotient of 32 and x, we're looking for 32 divided by x, okay? Or you could write it as 32 divided by x in that way, okay? However you want to write it, it's 32 divided by x, okay? So you'll notice all of these verbal expressions, to change them to mathematical expressions, you've got to focus in on the key words. So we focused on quotient on that one. So let's look at number two. Number two, the sum, that's the key word right there. The sum of x and 12. Sum means addition. The sum is a result of an addition problem. So the sum of x and 12 means x plus 12. Okay? Okay, number three. 19 decreased by n. So decreased is our key word here. And decreased in math means you're subtracting, right? And if we're subtracting by n, so it'd be 19 and decreasing by n. Okay? So, and also, before I keep going, let me write up in this corner here. So sum equals addition. Okay, so if you hear sum, you're adding. If you hear, let's see here. So if you hear quotient, there we go. Quotient means dividing. And if you hear product means multiply. Okay. And if you hear difference, in this case it was decreased, but difference means subtraction. Okay, so hopefully those will help you out as we go. So let's go to number four, all right? So number four, 14 more than the difference of x and y. So there's a couple of key phrases here, more than and difference. 14 more than means we're going to probably add 14 to whatever we have at the end. So the difference of x and y means difference. If we look back at the top right here, difference means subtraction, right? Okay, so the difference of what? Well, of x and y. So if I do x minus y, that's the difference of x and y, okay? And then, let's say I put those in parentheses. Once I find that difference, 14 more than that would be just adding 14 to that result. Okay? So let's go to number five. Number five, let's use blue on this one. So number five, the sum of 6 multiplied by A and 8 multiplied by B. Okay, so there's a lot going on here. The sum, that's a key word. Multiplied by and multiplied by again. All right, the sum of everything else. So we're going to add everything else that's going on. So first what's going on is 6 multiplied by A. So 6 multiplied by A, that is going to look like 6 times A or 6A. All right. And then we also have 8 multiplied by B. So that's going to look like 8B. And it says the sum of all of that. So those two, that means, are being added together, those two terms. So 6a plus 8b is the same thing as the sum of 6 multiplied by a and 8 multiplied by b. All right, number 6. Number 6, the quotient, so division, of m and 7. All right, so first I know we're going to be dividing m divided by 7. I'll write it as a fraction. M divided by 7 decreased by 10. Boom, there we go. M over 7 minus 10. Okay, so we had quotient to tell us division, decrease to tell us subtraction. All right, number 7. Number 7 says twice x. So if you would do twice anything, right? If I said, if I was given a portion of food and I said, can you give me twice that amount? That means we're doubling it, right? So if you were to double x, it's just 2 times x, right? If I doubled my portion of dinner, it'd be 2 times the amount of my dinner. So that's it, just 2x. Okay, number 8, half of u. Well, if you have u and you want to cut it in half, you just divide it by 2. Okay, that's it. It's just like anything. If you want, if I have a portion of dinner and I say, can you give me just half of this? They'll just divide it into 2, right? So divide it by 2, and then you have a half of whatever you were dealing with. So number 9. Number 9, we have 5 less than 3 times x. So if I have 3 times x, which is 3x, okay, and then 5 less than that means minus 5. 3x minus 5 is 5 less than 3 times x. All right, we're almost done. Last 3. So number 10, we'll use green on this one. Number 10, 7 times a number, so times a number. So we don't know what that number is, so we'll just use x for the variable to represent that number we don't know. So that'd be 7 times a number is 7x. And that is going to be increased by 4, so plus 4. Okay, number 11. Let's do orange. 6 decreased by 5. So 6 decreased by 5 is 6 minus 5 times a number. So whatever 6 minus 5 comes out to be, which we know is 1, times a number, so times x. So 6 decreased by 5 times a number. Oh, I'm sorry. I read that wrong. So what it actually is asking us to do is 5 times a number, which is 5x. We could just use x to represent a number. And then 6 decreased by 5 times a number means, oh no, I'm doing it again. Okay, hold on. So we've got 6 decreased by 5 times a number. So 6 minus 5 times a number. 6 decreased by 5 times a number. So 6 minus 5x would be that expression algebraically. All right, so lastly, we've got number 12. So number 12 says 3 plus the product of x and 5. Product, if we look back up here in the top right, product means multiply. So the product of x and 5 means multiply those. So that'd be 5, x times 5 is 5x. Okay, and 3 plus that product. So 3 plus 5x, the product of x and 5. Okay, so there's a bunch of examples. Hopefully that helps you how to better understand how to translate verbal expressions to algebraic or mathematical expressions.